Good afternoon. Now let's talk about holistic network automation or holistic automation in general, in this case, especially with the focus on networking. And as you can see, I have some strong opinions on these topics. So let's see if we agree in the end. I'll go to a little bit of history, where I'm coming from, why I have those opinions, some brief overview about some software engineering methods. Disclaimer, I'm not a software engineer by heart, so I may be stretching this a little bit. Please bear with me. And then we'll talk about how we can apply those software engineering methods to network automation and do a little bit reality check and Q&A. Who am I? I'm Max. I'm a network engineer, open source hacker, fanboy of Debian and Linux. I'm working as a network automation engineer at Cloudflare, but I'm not speaking for my employer, just for myself. Also, the lead architect of the FFHO community network and consultant for hire. You can follow me on Twitter or write me mails. Okay, so a little bit of history. My first job was in 2004, the Institute of Mathematics at the Paderborn University. First student job, big network at the time, like 100-ish, 150-ish, if I remember correctly, Linux workstations, servers, a little bit of Windows, which was, for me as a young boy, big. It was more or less a separate thing in the university context, so we had our area where we could basically do what we want to make it work. It was fully automated, like fully automated installation. Thomas is sitting here. Actually, we used Phi. And on top of that, we built or had some management tools to make all boxes of the same role the same. It was a homegrown S deployment. If I remember correctly, it was written in shell, which today scares me a little, which had the purpose to install additional packages and maintain the configuration files. It owned the full configuration, which at the time was a novel thing. S deployment had been around for a while. It was initially written for Red Hat, but then we migrated it as we did a migration to Debian and rewrote parts for packet handling, for example. It was not that cool as today's solutions, like you had to specify all Debian packages, including every dependency in the database. Otherwise, things would not be like you wanted them. And it even helped to find an intruder. Someone managed to hack our SSH gateway, which was not that cool. But the new SSHD binary they installed did not support Kerberos, which we were using. So the config file, which they also had replaced, was overwritten and then failed to restart. So we found something like, I believe, 7-ish or so with this. We did not want to use CF Engine, which was big at the time, which did incremental config changes, like add this line, remove this line, comment this out, or change something, which basically is like, okay, I'm using SED or a Perl script to fiddle with existing configurations, but in the end, I do not know what the exact content is, or can more or less hope. So seeing this early in my professional career shaped my line of thinking, like, okay, it's cool to manage the whole configuration of something, and this scaled right well for the scale needs at the time. When we go from that point in time to today and look about the more common solutions, which you likely have heard of, at least Puppet, Chef, Salt, or Ansible, I would assume everyone here has at least heard of one of those or used them. Before today, about Bar 2, Christian Theuner, who also gave the keynote, introduced the tool which he built in 2012. And when we look at the timeline, we see some of them are rather old. Common ones used today are quite recent. Okay. Okay. So then we put this here. Cool. So the goal of those tools is you describe the desired state, not the way to go there, but what do we expect in the end, like install this package and not have to put all packages, including dependencies, into an SQL database. Or this should be uninstalled, whatever. We want to have a file there or not with specific content, like a configuration file for network interfaces or for your service, Nginx, Apache service, whatever. And then restart services accordingly, like, okay, we changed the Nginx configuration, we now need to trigger Nginx to reload it. This can be built as like the intent. Okay, do this, do this, do this in this order, please, thank you. This is cool. For Linux boxes, even at scale, this is the common way of configuring stuff today, and make sure that you have a homogeneous configuration among the infrastructure. How does this look for managing networks? It's a very broad spectrum. Some operators still love typing or pasting magic spells into a CLI. Some of them even love one specific CLI and don't like to look about the other side of the fence and what's out there. Some deployed helpers in many languages, fashions, colors, and tastes, which you usually call with explicit parameters. Like, okay, set up a BGP session to this neighbor with this AS, this peer IP, local IP, password, whatever. There was some kind of evolution. The first thing I saw was expect, which is a dialect of TCL/TK, the elderly remember. Perl scripts, Python scripts, etc. This could even be based on Salt or Ansible. So you can hold those tools like this. There are some vendor solutions out there of different colors and sizes. Could be small-ish to fully vendor locked in. Hello, Cisco ACI. And some homegrown solutions anywhere on the spectrum. Like, okay, I wrote this little tool to do X. I wrote a full-blown SDN. I guess the top end of the scale would be Google size magic solutions, which they use, to my knowledge, to run their data center networks, which is not based on open routing protocols, but for example, like gRPC between the systems, because they just implemented what they really need. Okay. Where does this leave us now? Wouldn't it be cool to remove all the toil in SRE speak, like repetitive manual work, from network configuration management? So network engineers can focus on engineering instead of typing, pasting, whatever, config into devices and making sure they are doing the right thing. Follow the process, don't leak routes, which I would never have done. To have a vendor-independent solution, especially now that we have shortages with supply chains. Like if I want to buy some Cisco switches today, it may be 1 year ahead in time where I may get them, or some months earlier if I'm lucky. It would be cool if that could be tested, which would not to be happening in the network, like testing a piece of software automation before it touches my devices, before I got tweeted about leaking routes. That would be cool, right? That also scales well, because if we want to become the next Google hyperscaler equivalent, it would be cool if it scales. And we are here at the FrOSCon, so open source would also be great. I believe we can build that. How would we do that? So let's have a look at some software engineering methods, which might be useful here. First one, abstraction, which is a common pattern. We see it in a lot of places, like common operating systems, drivers for hardware, components for mice. So this basically is a mouse I plugged into my computer. I did not have to install a driver because it identifies as a HIT device. There is a generic driver. I plug this USB stick in, and it just works. Same for displays, I/O devices, file systems, any storage stuff. We have levels of abstraction within the operating system which make all of our lives easier, developers, users, etc. In the networking world, we have something similar, the commonly known ISO-OSI model with 7 layers of the networking stack, which is a bit theoretical. Level 5 and 6 kind of exist or do not. So we have the hourglass model, which is a similar approach. it could be argued that even 13 exist. We have internet protocols like HTTP to get the new cat videos from YouTube, SMTP to get spam, etc., which are all open standards. Same for routing protocols, OSPF, ISIS, BGP, which if we would not have those, it would be hard for routers and networks to interconnect. So we have open standards, which are kind of abstraction, to distribute routing information between routers and ASs. Okay, seems like a cool idea. And for a vendor-neutral solution, we would need something like an abstraction to get the router type or the operating system out of the equation. How about providing it does the right thing? Testing. If we write software, we usually, hopefully, build unit tests to make sure that functions, method, components, classes, whatever, do what they should. So white box testing. We know what's happening inside. Let's build some test cases which we know should fail, test that they do. We know some test cases or some inputs which we know should do A, B, Z. We test that they do. So a good coverage about that would be cool, like coverage report with code-conf or something. Integration testing, which would be good for APIs. Like I have this thing I just wrote, for example, a BGP daemon, as the co-author of biorouting. It is nice to see that our software can talk to BERT, FRR, or commercial vendor solutions, because if it does not, we did something wrong. Last but not least, which isn't a total different category, but it's another motivation to write tests, regression testing. Something broke, we fix it. We want to know if it breaks again, because if we can find it in the CI/CD pipeline where we run the tests before we merge something, we don't ship it to users, which need to complain to us. So we can find it and fix it before it goes out, which especially if we want to build automation to control our network without, when it does not work, our entire production is dead. This would be good, right? Okay, now we have tested our building blocks. We can plug them together. We can build a pipeline. We will need some kind of input, which goes to one process or many, depending on how we want to split it up, like microservices or whatever. And we have some output, which might be the configuration. Okay, now you might wonder, well, that's all old news. What he's talking about, I've heard this before. Cool. What does this have to do with network automation? Well, let's apply this. Abstraction. We need some way to codify our network so we can work on it and the processes or the controllers can do the right thing and generate the right directives. So we need some kind of topology and some rules. We'll look into that in a second. Next thing, we need to know the vendor configuration details. Like if you have configured some switches, routers before, you know there are different dialects or even languages. Dialects, for example, all of the interfaces which stole from Cisco, and then by meaning of some lawsuits had to fiddle some switches there and there. So it's more or less the same. If you know one, you will find your way on another, but it's not the same. All different languages. For example, Cisco versus Juniper versus Nokia, which are totally different. Okay. So what does topology mean? If you look at that, that's a drawing of a network. Network architects love to draw networks. It's true. To visualize what we are talking about. That's a brief overview. We have some core routers in the blue box, some nut boxes connected to the core, and some building routers which are also connected to the core, and some data center stuff. So with the rules we have in mind when we configure this, or with our architecture, we would say, okay, we set up OSPF between the cores and IBGP. We set up OSPF between the cores and the distribution routers, and IBGP to learn the routes, etc. So that could be rules which we need to apply. Another example, the FrOSCon Hochstift backbone on an abstract, simplified version. The green boxes are data center POPs locations. The, I guess here brownish or purplish on the beamer, and blue ones are backbone locations where we may have access points or not, where we may have Wi-Fi backbone links or VPN links, which can be interconnected by any means. So the rules will be more involved because we have different versions of how can a POP look, how can the interconnection look, etc. Same thing here. We have core routers, we have backbone routers. So the cores will be connected by some routing protocol, backbone routers too, like OSPF, IBGP sessions, etc. pp. Yeah. You might notice there's no vendor or device type in the drawing. In neither of those, I told you about, is it Cisco, is it a Linux box, whatever it is. Because on this level of abstraction, it's not that important to get the idea. So for the big picture, we don't need this. So if we translate this into software, we come to graphs. What we basically did, we drew a graph, an unidirectional, undirected graph, sorry. So the nodes present devices, routers, switches, access points, and the edges represent links. And all of them have some attributes, like a status. Is this device in production? Or will it be installed? Will it be decommissioned? Is it broken because reasons? What's its role? Core router, backbone router, edge router, switch, core switch, access point, whatever. What operating system is running on it? Because that we will need later on. What interfaces does it have? What IPs are configured there? What's the location it's in? Location could be from rack to a suite in a data center, to the DC it is in, the site, a metro, a region, or even a continent, depending how big my network is. From all of that information, I can derive stuff, like if a connection between two of those, an edge in this, is within the same rack, I will likely apply different rules to this link, rather if it's a link between, let's say, Frankfurt and Sydney, because they will behave differently. Also note that no BGP's neighbors are explicitly mentioned here, or IBGP metrics or something like that. Okay, cool concept. How would we get there? That's where the rules come in. What would an operator configure manually if they did the right thing? Like if the same operator or the one operator which runs the network, or many of them, but let's focus on one. If that person is to follow the architecture guide and configure the same thing everywhere, which likely does not happen if it's multiple people, but what would that rule be? Okay, so we are back to all our core routers, or our routers are in OSPF, area 1, speak OSPF, we learn the loopback IPs, we set this up on internal links, Wi-Fi, dark fiber, waves, VPNs. We derive the metric, for example, by the bandwidth. Like we will treat a 10 gig link or a 400 gig link likely different than a 100 megabit DSL line in regards of metrics, for example. We could cheat if we don't have direct links and use VLAN IDs to derive this, for example. All core routers and everything else speak IBGP. So a long list of rules, how you would set this up. You could even automatically generate your firewall rules for control plane policing. Because if you know this box will have all those BGP neighbors, you can generate control plane policing rules for this. Or stuff like unicast reverse path filtering, same thing. If we know what prefixes will be connected to which interface, we can and should filter. Okay, how would we build that? That's where pipelines come in. The input could be something like a netbox or Nodobot, which are an infrastructure resource modeling system, at least Netbox is calling itself that, or a data center information management plus an IPAM. So we have this box, it's sitting in this rack at this site. It has a cable to this box sitting at that rack and that site. We have IPs on those interfaces. We have some prefixes assigned somewhere, etc. If you are an ISP, you will likely have additional data sources like subscriber database. This customer is sitting there, has a DSL on this platform, has this bandwidth and this service contract, yada, 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 or whatever services you provide. So most likely it will not be one single source of truth to stretch that term a little, but multiple. Then we have a process or multiple of those, which gets this topology information, mangles them together, this is multiple, and applies the rules. First good step would be to generate the vendor neutral configuration. So if we have that, which can be derived, topology plus rules, like set up OSPF neighbors, set up IBGP sessions, for example, which we don't need in a vendor-specific format yet, we can then translate this bit, which would be our global configuration of our network, into the vendor-specific configuration of our devices and translate it into the languages or dialects. And the pipeline could also apply this config. Cool would be if it can do that as an atomic operation, like for example on Juniper boxes load replace, we generate the whole config. Going back to the salt Ansible discussion, this automation owns the full configuration on the device and does not fiddle with it incrementally. Like we don't go there and configure an additional interface because we have calculated that this needs to be added. The ultimate goal would be, I don't know how reachable it is with different vendors, to generate the whole configuration, push it to the device, and let the device think how to come from the current running configuration to the new one. Because the device should know best. I know that Juniper can do this, and some others can. So we have talked about multiple steps, so it might be beneficial to go for a microservice approach. Could scale in Kubernetes or whatever. Well, and the output of this pipeline is the complete generated configuration. And as I said, depending on where you look, could be also the steps in between. Okay. So what I just described could look like this. We have the different components and a chain of controllers, translators, etc. And one example was like Juniper box, which would be one long piece of text. And then we could have disaggregated boxes like, for example, Cumulus or Sonic or whatever, where we need multiple configuration files. Like on Cumulus, for example, etc network interfaces for the Debian-based system and FRR.conf for routing, authentication, yada, yada, yada. For Sonic, I don't know, because friends don't let friends use Sonic. The translator in this picture could even be something like SaltStack or Ansible, if you want to, or homegrown. Okay, last bit. We need to test this, right? We don't want to do a Facebook. So if we are doing multiple processes, we can test all of them as one unit and every piece of that. The controller can be easily tested without touching the network because it's just generating some neutral configuration, which will never hit the device anyway. So we can set up a special netbox, for example, or mock a netbox with a static set of data, which represents all the magic bits without in our network. So we have a kind of lab environment it has everything in it which we need to generate all the or test all the cases we have, and then check what the result of that is. If we change the code to bug fix something, the result might not change or should not change. If we add another feature to support feature X on the platform, the device should change. Do we see this change? Translator can be a little bit harder depending if it's touching the device directly or not. If the translator is going from the vendor neutral configuration to the vendor specific configuration as a text file, it's the same. We can have a fixed input, fiddle with the translator, see if the output still matches or has new config for feature X. And we can test all this in a CI/CD pipeline. So no risk of impacting our infrastructure, and we can build trust into our system. And we can even set up a lab from our CI/CD pipeline, like spin up a lab with whatever devices for whatever roles we have, generate the config, push it there, see if the devices complain or if something blows up. That would be cool, right? So now that we have tested the abstract building blocks, we can plug them together, have a nice solution, and rainbows and unicorns. Reality check. Does that exist? I know of at least one implementation which basically does that, which is not open source, which is sad. I have built something similar with Salt for FFHO, for the FrOSCon network. I have the logic in Salt, and I heavily regret this life choice. There are some lessons I learned from that. Storing data in Pillar, which is the key value YAML thingy inside Salt, seemed cool many years ago. It does not anymore. It doesn't scale well, and it limits the flexibility a lot because this data is only available within Salt, or you need to build another parser, which basically parses all this YAML hierarchy to extract the bits you need to do something else which you want to do outside of Salt. I started fiddling with this in 2015, I believe. I've rewritten the whole thing once, I believe 1.5 years in. Over the years, this thing shifted from getting the input into Netbox, which was finished this year, and life was easier since. So the pillar inside Salt only now has information which is relevant inside Salt. So I have the whole topology in Netbox. Having logic in Jinja templates is also for people who hate themselves, because Jinja is very limited in what you can do. Like declaring a variable before a loop in Pillar, you cannot write to it. You could just append something to a list or a dictionary, but you cannot switch a Boolean flag by a for loop, for example. And it's only within Salt. Having logic in Pillar also seems wrong, because the idea of Jinja is a template. Like, this is the input, make it look nice so a device understands what we want. So we should focus on the building blocks we use. Then some years ago I started, I'm not sure, 2 years I believe, I started to write NHCL, Netbox Abstraction and Caching Layer. The C is not part of it yet, and it's ugly spaghetti Python code, but now I know what would be good. Which gets everything from Netbox, mangles the data in a format which is less verbose, because getting data raw from Netbox is very verbose. Builds some kind of a graph from it, and then generates bits. So for example, the logic to build the IBGP mesh. So core routers are route reflectors. They have IBGP sessions without being an RR client, and every other router is an RR client to all route reflectors, is now part of NHCL. So we generate the BGP neighbors of a box, push it into Salt, and the Jinja template just builds a bird config from it. This was part of a Jinja template before, the logic bit, which now got out there, which would be cool. So now it's possible to use the information on the topology to build monitoring. Like, I expect these BGP sessions here. Are they there? Are they up? And the idea is, in the end, to just use Salt as the translator from the generic config to what I need in etc network interfaces, birdconf, etc. pp. So you likely have some questions. I have some answers already. Why not generate the config within Salt or Ansible? Because it's painful. How do you test that? If the idea is to have a Salt minion which directly goes to a device. What can I put in between to test what it will do there? That's not trivial. How about testing this automatically? I'd like to hear your approaches if you have some. I don't know any. And you are limited to Python and the environment Salt will give you. You can build some all Python modules, put it into Salt, but it's still running inside the Salt box. Why not go to Cisco, buy ACI, live happily ever after? Because likely you won't. It's the full vendor lock-in, it will cost a lot of money, and for example, I'm not sure if this is still true, if you want a layer 3 route from ACI to a /64 IPv6, you would technically have to add a lot of 1/28 host routes because it cannot do that, for example. If you are not big enough to make Cisco add this feature, what now? Why not use netconf and YUNG? Because it's the new holy grail, it's a good abstraction. Kind of. Some vendors have vendor-specific endpoints and models, for example, for some BGP implementations. So we still have the problem. We need vendor-specific code to go to the API, which should be a common one, because it isn't. It's not a fault of the model, but of the implementation. But also, usually it's used to do incremental changes to the configuration, which I would not like to do. We could use netconf to push the whole config, but then what's the point? We could just use SCP or SSH, but would be possible. So now, up to you. Are there any questions? I believe we have a mic. I know someone was skeptical before. I believe she's gone.
Hi, Max. Regarding the NACL thing you have developed there, since around about 1 or 2 years, the Netbox APIs for plugins or the plugin SDK for Netbox has really improved. So wouldn't it be a good idea to add this as a kind of hook into the API? So you could rely on tags or roles and do this kind of calculation, this kind of add on to Netbox, to your topology automatically in Netbox environments.
So the idea is to write a plugin to Netbox
Yes.
/in Netbox, which generates the vendor-neutral configuration?
No, the iBGP mesh, for example. So you have the configuration inside Netbox or kind of inside Netbox.
So you want to store it explicitly, or you want to just generate it?
Generate it on runtime.
Okay.
Because from what I got, this is what you are currently doing. So it's kind of a runtime generation of the iBGP configuration.
I'm not sure if it's possible to do that. I guess you could, but I would not like to do it because it would mix two things. For me, Netbox would only be the data store, like the model which holds my topology information, and then I get all my topology information and then apply my rules. So I would not like to mix this.
Okay, understood. Thanks.
So I actually have a question. How do you go about devices that do not support replacing the full config, like you said, Cisco can do sometimes?
Cry into your pillow. The idea there would be like FRR does, for example. FRR is based on the Cisco CLI, and they developed a Python script which looks at the current configuration and then tries to generate config directives which overwrite existing config if it's not there in the new version. So it basically creates the diff for you. So this would need to be written into the translator, for example. And what I also would like everyone here to do is go to the vendors and say them, please build this. Because I think we all would benefit from it.
since nobody else has questions. Reality check, what do the great network users, vendors, whatever, actually use? Because I imagine Amazon, Cloudflare, Facebook, Level 3 have some solutions for this. I cannot imagine Amazon engineers fiddling with thousands of routers manually.
For Amazon, I really have no idea. And as I said, I'm not speaking for my employer here. So basically, for the big ones, I don't really know. I believe there are some papers out there for Google, for I believe B2 would be, or B2, B4, I'm not sure which one it is, would be a good search keyword. I'm not sure if the current architectures are open, but they are so big and have so much brain power and money and are so specialized because they have, I don't know how many data centers, but not as much, but big ones. They have very specific problems there, which, as I had somewhere on the slides, requires specific solutions. Okay, thank you very much.